Hello! Today we continue our study of chemical reactions and find out how we can categorize these chemical reactions. We will show the classification of reactions. So we already know that reactions come in compounds. And let's give an example of such a particular chemical reaction here. So this will be a reaction. For example, calcium reacts with oxygen and the reaction produces calcium oxide. Don't forget that any equation has to be equated, so we'll put 2 in front of calcium. And we'll put 2 in front of calcium. A coupling reaction is recognized by the characteristic that more than one substance reacts, but the reaction produces one compound. At the same time, I would like to explain one more point. The point is that this reaction belongs to the category of so-called redox reactions. These are reactions in which the degree of oxidation changes, but I cannot say that any reaction of a compound will necessarily be redox reactions. Here is an example of a coupling reaction that is also a coupling reaction, but which would be the opposite of a redox reaction. For example, magnesium O, magnesium oxide reacts with carbon dioxide. With carbon dioxide to produce magnesium CO3. Let's check the coefficients in this case. Additional coefficients are not required and this reaction will be accordingly not a redox reaction. Hence, it turns out that coupling reactions can be both redox reactions and non-redox reactions. The second type of reaction is what we call decomposition reactions. These are reactions in which several simpler substances can be produced from one complex substance. Here's an example. Again, let's first give a redox reaction, for example, the decomposition of water. Water, under the action of temperature, or it could be an electric current, can decompose into hydrogen gas and oxygen gas. We don't forget to equate. Accordingly, then we put a factor of 2 in front of the water formula and we put a factor of 2 in front of the hydrogen formula. This reaction is decomposition, but this reaction is additionally also a redox reaction. So, let's give an example of a reaction that is not. One of the very common reactions, I would say, one of the first reactions that man learned to produce in industry is the decomposition of limestone, which under the action of temperature decomposes into calcium oxide, this non-calcareous known substance called, and carbon dioxide. This reaction will be accordingly. No coefficients are required here. It will not be a redox reaction. So now the next point, the third kind of reaction is substitution reactions. These reactions are called substitution reactions, but substitution itself is divided into 2 types. It can be simple substitution and double substitution. We'll show the substitution inside, which will be simple substitution. These are reactions, for example, zinc. The metal zinc reacts with water vapor and under the influence of temperature, zinc oxide is produced and hydrogen gas is released. In this case, the coefficients are not required, and I would like to draw your attention to the fact that if, for example, the reaction of combination and decomposition can be both redox and non-redox, such a reaction will always be necessarily redox. It will be strictly obligatory because it cannot be any other. Now, if we're talking about of double substitution, and this reaction can take place, for example, if a so-called precipitate is formed, that is, one of the substances turns out to be solid, but it's also possible to have two substances, but it's a rare case. Here's an example. Let's say silver nitrate reacts with hydrochloric acid. There is an exchange or double substitution reaction. We get argentum chlorine. We can show it as a precipitate symbol, so sometimes we can show it. And the second will be nitric acid. No coefficients are required in the reaction equation. That's the first case. Now, the second case, when there is a so-called acid-base interaction, acid and bases, when they react. So this reaction is also additionally called neutralization. Here's an example. It could be the interaction of sodium OH and, let's say, nitric acid, in which case you would form sodium NO3, the salt sodium nitrate. And the second one would be water. And here is the presence of water. Water is a weak electrolyte, hence the reaction will occur irreversibly. Coefficients are not required. And then amongst these reactions, there are gas formation reactions, where a gas is formed. Here's an example of such a reaction. Potassium C, potassium sulfide, reacts with hydrochloric acid. An exchange reaction takes place. Potassium chloride is produced and hydrogen sulfide is released as a gas. Let's equate potassium on the left side. Here, 1 in front of potassium. Chlorine will put a 2. Further in front of chlorine, we need to put a factor of 2 also. And such a reaction is irreversible. And now pay attention. In these reactions, such a reaction is always, I will write it here with an asterisk as well, that it will always be necessarily not redox, it will always be necessarily so. Well, to be fair, there's another kind of reaction that we emphasize in a special way, and that's the combustion or oxidation reaction. Is a reaction that takes place with oxygen. And in this case, if it's accompanied by the release of heat and light, it's called combustion. Here is an example of such a reaction. For example, if we take the combustion of a simple substance, this is the combustion of coal occurs like this. Then, as a result of the reaction will be released carbon dioxide. Coefficients are not required. Then this reaction, if we look, it looks like naturally this reaction will be a coupling reaction, but it can also be referred to combustion reactions. Now let's show an example. If we take methane, methane is a natural gas, which is very often used in our homes as a burning fuel. As a result of the reaction, we get carbon dioxide and water is released. Next, if we equate, we get 2 in front of the water formula, and to the presence of oxygen, we need to put 2. What we can say about this reaction will always be a redox reaction. Compounds, decomposition, substitution and combustion, but plus we've included here the classification of, for example, a redox reaction and a non-redox reaction. And to summarize, here let's show coupling reactions can be both redox reactions and non-redox reactions. Decompositions can be both redox and non-redox reactions. Substitution reactions, if it is a simple substitution, will always be redox reactions. If it's double substitution or exchange, it will always be non-redox. Well, the wonderful combustion reaction, it will always be redox. So I hope our lesson will help you navigate these reactions and you won't make any mistakes. Well, that's all for today. Goodbye.